This will be for the con exercise, connecting exponential graphs with context. All right, so notes, the y-intercept is the initial amount at x equals 0. Okay, in order to find the horizontal asymptote, in other words, where y is headed, you can just use the calculator repetitively. Okay, but this sort of goes back to the old exercise where we said if b is less than 1, it's a decay, and b is greater than 1, it's a growth. But we'll do more on that on the actual problems. All right, so it says Fidel has a rare coin worth $500. Each decade, the coin's value increases by 20%. He graphs the coin's value. What is the significance of the y-intercept? Okay, so remember, we said already the y-intercept is the value of A. Okay, and that is your initial value. All right, and that's basically at x equals 0. So it says the initial value right here is $500. So that would be your y-intercept, and that's basically it. That's the initial value, we could say, at x equals 0. All right, in this case, since x is the number of decades, we could say at x equals 0 decades. All right, but that's it, really. You just have to put it into words. Okay, $500 is the initial value at x equals 0 decades. All right, so this is 0 decades, but it says 600. This is 0 decades. It's worth 500. So that's it right there. Answer D. All right, a sample of bacteria was placed in a Petri dish. The number of bacteria changes exponentially over time. The graph describes the number of bacteria over time in hours. Okay, so y-axis is number of bacteria. X-axis is time. We can see it's an increasing function. What is the sample's initial size? Easy. We said the y-intercept is the initial value. Here's the y-axis right here. That's a 50. That's it. That's your answer. All right, no units. It's just 50 bacteria. All right, Fidel has a rare coin, $500. Each decade, it goes up by 20%. Which graph shows the coin's values, the correct value? Okay, so I say we write a little equation first here. All right, in order for something to increase by 20%, if you start with 100% and you add 20%, that's going to be 120%. Okay, but to multiply and add 20%, we need to convert this to a decimal. If you move it over 2 places, that's just going to be 1.2. All right, you can make it 1.20, but it's really just 1.2. So as we've been doing, y equals a times b to the power of x. We said a is the initial amount, that's 500. And b is what you are multiplying by each time. Well, in order to increase by 20%, you want to multiply by 1.2. Okay, this will increase it by 20%, like we just calculated. So the value for b, in order to increase it by 20%, is going to be 1.2. So what does that mean? Well, if the initial value is 500, the next one is going to be 500 times 1.2. Okay, and that basically equals 600. So, At x equals 0, it should be at 500. And since we say the exponent here was just 1, we multiplied 1.2 one time. That's basically what we did here. The 600 would be at x equals 1. All right, we basically only multiplied it one time. So we just want to find the graph where this is true. All right, so if you scroll down, it should start at 500, and then at x equals 1, it goes up to 600. 600 would be, it starts at 500, but 600 would be less than halfway up. Right here at x equals 1, this is more than halfway up the block, so up the square, so that's no good. All right, this one does not start at 500. This one starts at 5, and then at x equals 1, this is about 600, okay? It's less than halfway up the square. So I say it's answer C. This one doesn't even start at 500, okay? So yeah, here's 750, here's 500. 600 would only be about right there, okay? It's not even halfway up the square, because 500 to 600 is an increase of 100, but then 600 to 750 is an increase of 150. So to go up by 100, that's not even halfway up the square, okay? So that's definitely going to be answer C. All right, forest has 800 pine trees. A disease is introduced. It kills a fourth of the pine trees every year. Which graph shows why pine trees X years after? All right, so let's see. We're going to start with 800. This is the initial amount. And this is going to be at x equals 0. Okay? And since it kills a fourth of the pine trees, what exactly happens? Well, you're going to lose 1/4 every year. All right, you're going to lose 1/4 each year. So, what do we multiply by to make it lose 1/4? Well, if you start with 100%, which is the same as 1, and you lose or subtract 1/4, what's 1 minus 1/4? Well, that's just 3/4. Okay? And what you do with that 3/4, you multiply by 3/4 in order for it to lose 1/4. All right? So basically, you take your 800 and you multiply it by 3/4 in order to make it lose 1/4. So I'm going to do 800 times 3/4. All right, let me see. 4 into 8 goes 2 times. Yeah, so 800 divided by 4 is just 200. And then 200 times 3 is 600. So the initial amount of 800, that's at x equals 0. We only multiplied it once. So it's going to be 600 at x equals 1. All right, so we want to look for the graph that starts at 800 and then it decreases to 600 at x equals 1. All right, let's take a look. All right, this one doesn't even start at 800. This one starts at 8, and this is x equals 1 right here. It's in between 0 and 2. At x equals 1, it goes down to 600. Perfect. Double check. This one does not start at 8. This one starts at 8, but then at x equals 1, which is right here, it goes way less than 600. Remember, we said we wanted it to be 600 at x equals 1. This one goes way down lower than that. Okay, so it's definitely answer B, because right here at x equals 1, if you trace it up, y equals 600, and it starts at 8. All right, one more. A computer is sold for a certain price and then its value changes exponentially. Graph describes the value over time. All right, so the value in dollars versus the time. We can clearly see it's a decreasing function, okay? Reading left to right, it's going down. How does the value change? All right, so the ones where it says gains, that's definitely eliminated, okay? It's not going to be B or D. Here it says loses 50%. Here it says loses 25%. Let's see which one it is. All right, so the initial value is 500, okay? It starts at 500. And it decreases at x. This is the x-axis. At x equals 1, if you trace this to the graph, the y-coordinate is right here. It's in between 3 and 2. So that's going to be 250. So it starts at 500, and after 1 year, it's down to 250. Well, what did we multiply by in order for it to go from 500 to 250 at x equals 1? Well, let's figure out what this blank space is. We have 500 times this blank space. The opposite of times is divided by. All right, you want to do the same thing to both sides of the equal sign. 500s cancel. 250 divided by 500 is just 1/2 or 0.5. Okay, so if you started with 100% or the number 1 and you lost 0.5%, well, that's just going to be 0.5%. Okay, and moving the decimal over 2 places, 1, 2, that just equals 50%. So that's a 50% loss. All right, just to recap, we found this, whatever was supposed to be in here was what we were solving for. Whatever we multiplied times the 500, okay, is 0.5. When you multiply by 0.5, what does that do? Well, let's see. 1 minus 0.5 is 0.5. So that just translates to a 50% loss. Okay, just for hypothetical, let's say this was 0.2. Okay, and we did 1 minus 0.2 and we got 0.8. That would have been an 80% loss. Okay, but here we didn't multiply by 0.2, we multiplied it by 0.5. And I did 1 minus 0.5 to solve for the percentage lost. Just like I would have done 1 minus 0.2 if the number was 0.2. All right, so whatever you get here, just subtract it from 1 to find out the loss. All right, and that is clearly a 50% loss, which is answer A. All right, maybe one more. A container of liquid is left open, evaporates over time. The graph shows the volume over time in days. All right, what does the graph suggest about the volume beyond 28 days? Well, what's going to happen, this is just going to decrease, but it's not going to go below 0. Okay, basically you're going to have a y asymptote at y equals 0. And why is that? Well, this starts at 100 and it's exponential. So it's going to be multiplied by the same number each time. Let's just say, for the sake of argument, to go from here to here, to this point right here, and this is 70. Let's just say, for the sake of the argument, it's going to be 100 times 0.7. Okay, that's going to be every 4 days, but it doesn't matter. If you keep multiplying 100 times 0.7 times 0.7, and you keep going, the number is going to get smaller and smaller, and it's going to head towards 0. Okay, but it's never going to actually reach 0. Okay, if you did this on the calculator, if I could show you real quick. All right, so if I did 100 times zero point 0.7, and that would give us 70. All right, if I keep hitting equals over and over again, it multiplies by zero point 0.7 each time. And of course, notice that number just keeps getting smaller and smaller. Okay, it's never going to go below zero. It's just going to keep getting smaller and smaller every time I multiply times zero point 0.7. It will approach zero, but it will never reach it. So looking at their answers, no, the volume will not become zero and the volume will not become negative. The volume will continue to approach zero while remaining positive. Okay, and it's definitely not going to increase because it's a decreasing function. So it's going to go to zero, but it's going to remain positive. Answer C.